The paper discusses enhancing Taobao display advertising through multimodal representations, focusing on challenges, approaches, and insights. It proposes a two-phase framework to leverage multimodal data for improving recommendation accuracy. The first phase involves pre-training multimodal representations using semantic-aware contrastive learning, which captures semantic similarities among items. This method utilizes users' search queries and purchase actions to construct a pre-training dataset tailored for e-commerce scenarios. The authors highlight the importance of optimizing the contrastive learning process, particularly in defining semantically similar and dissimilar pairs for supervision. In the second phase, the authors integrate the pre-trained representations into the existing IDBASED model using two approaches: SimTier and the Multimodal Knowledge Extractor (MAKE) module. SimTier computes the dot product similarity between the multimodal representation of the target candidate item and the user's historically interacted items, then partitions the score range into predefined tiers. This effectively converts high-dimensional multimodal representations into an n-dimensional vector encapsulating the degree of similarity. The MAKE module addresses the issue of training epoch discrepancies between IDBASED and multimodal-based models by decoupling the optimization of multimodal-related parameters from that of ID features. The authors also present the design of their production system, which generates multimodal representations for newly introduced items in real time and ensures their availability for the training infrastructure and online prediction server. Since deploying multimodal representations in mid-2023, the authors have observed significant performance improvements in Taobao's display advertising system. They highlight the importance of addressing the challenges in adopting multimodal data, including the need to balance performance benefits with deployment costs. The paper discusses enhancing Taobao display advertising with multimodal representations, focusing on challenges, approaches, and insights. It presents a novel approach called SimTier, which utilizes tensor decomposition to obtain a better understanding of the complex interactions between user behaviors and item attributes. This method is designed to handle both sparse and dense data effectively, providing a more accurate representation of user preferences and item attributes. The authors also introduce the MAKE module, which consists of two steps: multipage training to extract useful multimodal knowledge and knowledge utilization by the downstream task. This module is trained using the center prediction task as the recommendation pre-training task, aiming to refine its parameters via training over multiple epochs and extract knowledge from multimodal representations. The paper also highlights the importance of industrial design for online deployment, particularly in maintaining prediction accuracy for new items. It outlines an online system that continuously generates multimodal representations for new items and utilizes them in real time. This process ensures minimal latency between an item's introduction and the utilization of its multimodal representation by the model. The authors conducted experiments to evaluate the performance of their proposed methods, comparing them with other widely used pre-training and integration methods. The results show that the proposed SCL pre-training method outperforms other semantic similarity agnostic methods, emphasizing the necessity of semantic-aware learning. Additionally, incorporating techniques like momentum contrast and triplet loss further enhances the quality of multimodal representations. In the center prediction dataset, the proposed SimTier and MAKE methods significantly outperform other methods, with the combination of SimTier and MAKE providing the best performance. Overall, this paper presents a comprehensive analysis of enhancing Taobao display advertising with multimodal representations, offering insights into the challenges, approaches, and significant findings in this field. The paper also discusses the integration of multimodal representations into the Taobao display advertising system to enhance the click-through rate, center prediction model. The authors highlight the challenges of incorporating multimodal data, including the need for high-quality representations and efficient integration methods. They propose a two-phase approach involving pre-training and fine-tuning of the multimodal representation model. The authors demonstrate the effectiveness of their approach through experiments, showing improvements in center prediction performance. They also explore the impact of pre-training epochs on the final recommendation model, finding that multipage training enhances model performance. Furthermore, they assess the generalization ability of multimodal representations on long-tail items, observing significant improvements across all item groups. The paper also discusses the online performance of the multimodal-based recommendation model, which has been integrated into the Taobao system since mid-2023. This integration has resulted in substantial performance improvements, including a 3.5% increase in center, a 1.5% boost in revenue per thousand impressions, RPM, and a 2.9% rise in return on investment, ROI. Notably, the impact is more pronounced for new ads, with improvements of 6.9% in center, 3.7% in RPM, and 7.7% in ROI. The authors conclude by discussing related work in the field of multimodal-based recommendations and highlighting the valuable insights gained from their experiences during the online deployment stage. They believe that their strategies and insights will serve as a valuable resource for those aiming to expedite the adoption of multimodal-based recommendations in industrial systems.